Now, most of today's lessons are actually going to be discovery, but there is a few notes to go with this. So we're going to look at graphs of quadratics today, and just a reminder that the graph of a quadratic is just something with x squared in it, not 4 like it might sound like. And when you draw that shape, it's called a parabola, and it actually looks like the letter U. Oops. Now it says graph on your calculator and make a little sketch. So we sort of know that it's a U, but we'd like a little bit more details. So on the graphing calculator, if we go to menu, find where the graph is, and then we're just going to type in the equation y equals x squared. So I use the x and then the squared button. If I press execute, the equation's already in, and I just want to draw this, so you press the button that's lined up with it. And you can see you get that nice U shape, and you can see that the lowest point of the graph goes through the origin. That's an important characteristic for this graph. So a little sketch, hopefully try and make it touch the axis. Perhaps if I draw it this way around, I can do a slightly better job. There we go. Now this is quite zoomed out on here, so sometimes I want to change the window as well. So if we click View Window, this is in standard mode right now. Initial sometimes helps us to see a little clearer. So once you see the values have changed now, if you press Exit to go back, and then draw again, then you can see this a little bit easier. And all the little lines on the graph here are just representative of the numbers. So 1, 2, 3, 4, 5, 6, and on the y-axis 1, 2, 3, and so on. Now I then asked the follow-up question to the class, what does the graph of y equals x squared look like? And what does the negative do to the graph? So let's go back into here. If we press Exit to go back again, and then we can just type in negative x squared. Enter. And then draw, and you can see that the graph has been turned upside down. So any graphs that have an upside down U shape, we know are going to be negative x squared. Notice once again, the vertex goes through 0, 0, and that's quite important. Now, after this point, I let the students work on their worksheet. And this is what the first one looked like. So we just actually drew y equals x squared, so we know what this looks like. It's a U shape, and it goes through 0, 0. So off this graph here was graph number 1. Now x plus 2 squared I wouldn't expect you to know, so you just use your calculator. Let me go into graph again, exit to go backwards, and then we're just going to type in the equation just like it appears. So with parentheses, x plus 2 squared, and then we're going to draw. And what you should notice is the graph that was originally here has now moved 2 places to the left, which is actually this one down here. So this would be graph number 2. And actually it asks you to say this, x plus 2 squared is the graph of x squared moved 2 places to the left. Now another point to notice is, although this says plus 2, notice that the intercept here is actually at negative 2. And that's going to be an important observation for something that we're going to do on the next sheet. So on the second one, it asks you to graph an equation. So I'll do the first one. So it says that we're going to do x squared plus 2x minus 3. And actually I would like to get rid of that top equation. So I'm going to delete where it says del. And just ask me if I'm sure. Yes, I'm sure. And then let's draw it. Now I've noticed that this check mark here is gone because the graph goes through it. So this must be 1. And on this side, negative 1, negative 2, negative 3. So if I put the check mark at 1 and also at negative 3, then I've plotted the x-intercepts. Now the sketch for the curve, besides that, I'm really just looking for the U shape. So we could be even more accurate if we wanted to. This goes actually off the graph. It looks like it goes through negative 3 on the y-axis as well, and that shouldn't be that big of a surprise. If you want to find a y-intercept, you set x equal to 0 from an earlier chapter. So if I go ahead and draw this graph in, something like that. Now it asks you to solve this using the method from chapter 10. So this would be x plus 3, x minus 1, and then if we do the opposite, so instead of positive 3, negative 3, instead of negative 1, positive 1. And the question asks us, what do you notice about the x-intercepts and your answers? And what you should notice is they are the same. So another way of asking this question is to say, what are the x-intercepts of an equation? And what you do to find that is you set the equation equal to 0, go ahead and factor, and then do that opposite step to find out what they are. So there is a connection between the factors and the x-intercepts, and the fact is that they are exact opposites of each other. And we can refer to that as the factor theorem. Now there are a few more of those for you to try as well. We're going to move on to the third sheet now, and this is the same idea but in reverse. So if we look at the graph, can we figure out what the equation is? Well, I notice it goes through 5 on the x-axis, and it goes through -1. Now I can see the u-shape, so I know it's something to do with x squared. So I'm going to write the factors, but I'm going to put the opposite of what the intercepts are. So I'm essentially doing the reverse of what I did in the earlier section. When I had my factor, I did the opposite to find out what the intercept was. This time I'm going to find the intercept, do the opposite to find out what the factor is. Now this question says we're just going to write these in factored form, so I'm not actually going to multiply out using FOIL. However, once we get to the last one, then I am going to do this. So if I have an intercept of 5, then I need to do the opposite, so x minus 5. And if I have an intercept of -5, I need to do the opposite to find out what the factor is. Now I left room over here to work out what this is going to give us. So x times x is x squared, x times -5 is -5x, 5 times x is 5x, and 5 times -5 is -25. And then if I simplify all this, x squared, 5x take away 5x cancels. So I've got x squared minus 25. And I could actually check that on my calculator as well. If I type in, so I think I'm going to get rid of this previous formula that I typed in first. I think that this is x squared minus 25. So if I draw, you can see that it goes through 2, 3, 4. It does indeed go through 5, -1, -2, -3, -4. And it does indeed go through -5 as well. So it looks like I've probably found a good answer to that question. Now I'm going to do one more of these that goes down a little bit lower, and it's this one here. So a graph that has intercepts of 0 and -8, then -8 is easy enough, that's going to be x plus 8. And then for 0, it's tempting to want to put x minus 0, and I guess that's a good answer for this question. But what is x minus 0? It's just simply x. So I don't actually need this table for this question, I could just distribute. So x times x is x squared, and x times 8 is 8x. And I'm going to do one final one from this. I'm going to look at number 7. It says a quadratic graph has an x-intercept of 3, so only one intercept. What is its equation in factored form? Now it says look back on sheet 1, so let's go back to sheet 1. And notice these graphs here only have one intercept. What was special about those graphs? It was this thing here, but it was squared. So if it went through 2, I put, that was this graph here. If it went through -2, I put +2, I did the opposite, and then I squared my answer. So if I go back to this question, question 7, if it has an intercept of 3, I can put x minus 3. Really though, I know I need 2 factors, so all I'm going to do is I'm just going to write the same thing out again. So I could put x minus 3 squared, or I could just put x minus 3, x minus 3. There's a little space there if you want to check this, but your answer would be x squared minus 6x plus 9. Now if you're away, there is a copy of this worksheet on my website, so you should go and find that, and then you'll be able to catch up on what you missed.